Hold on, I wasn't recording. All right, let me just recap. All right, I was do a recap for intent and purpose. So we started out looking on the problem. The first thing we did was to find the maximum height of the problem. And how we did that, we said we look at step. We look at the components of the velocity due to VA. VA has two components, one in the horizontal and one in the vertical. So we went ahead and we found them, which was, I tend to call it UI and UX. So UI was 10 sine 30 for the Y component, and for the X component, it was 10 cos 30. That equals to 10 meters per second, and for the UX is 8.66 meters per second. We proceed now to actually calculate the height. We know that at the maximum height, the body will stop instantaneously. So that velocity at that point is becoming 0. And therefore, and the acceleration due to gravity is 9.81 because, and it is minus because it's going against gravity, are resistant. And therefore, we apply our first, we look at the first equation, but recognize that there are some deficiencies there because we didn't have the time, right, with distance we want. The second one, however, we saw that we have velocity and it just needed distance and we have acceleration. So we went ahead, used the second equation, which was v square equal to u square. But you notice these are vy, uy, plus 2g hx, which is the maximum. Transpose for hx maximum, and we have 0 here minus 5 square because the initial velocity using the trig for the y component is 5 square, and then we got minus 25 for that because when you carry it over it becomes minus. All right, so we consider that we square it from here, it becomes 25, so it's minus 25 coming across, right? And therefore so it's not like say it was a minus 5. It is the fact that it's the operation coming across. So you're subtracting from 0. And therefore, the gravity here is minus, which is minus 9.81. So we both minus cancel, you get 1.274 meters for the maximum height reach. The fact that we have maximum height, then now we can proceed to find the time to reach that maximum height. So we said it, and so the time of flight, first we need to find the time for it to reach a maximum height, and then we double it because we said that it is symmetrical. So we said at the time to reach a maximum height, first equation of motion Vy is equals to Uy plus At. Equation 1. At maximum height, Vy is 0, Uy is 5. So we apply this equation, and it is 0 from 5 is minus 5. And you divide through by minus 9.81, minus cancel, and your time to go halfway of the flight is 0.509, just midway, just to reach a mid section of the flight. When you're finished that now, we double it because we say it's symmetrical. We double this time and you get the total time of flight. So it's 1.094. Was that the correct figure? Guys, that's what we're supposed to have there. All right. That's, I'm just confirming that based on our discussion before. Want to make sure that incrementally we are using the correct figure. I think there are some persons who don't use. So yeah, we get 0.5096, double it, and we get in 0.0. There's supposed to be a 1 here. I think there's supposed to be a 1 right here. Yeah, I think that was the error there. Right. So so that is correct now. And then now we come down here and we show that we could also do it a different way to get the time of flight, using, considering that for the X and Y frame, right, where this would have become now the X-axis and this is the Y-axis, we're saying that the body, if you're considering the Y direction, at this point, the body will be 0. And the body will also 0 distant at that point. if you're considering the using the equation in the y, which is standard this equation here. S is equal to ut plus half at squared. So both distant at a0 and the distant at c, along the x, the y component will be 0. So both of them are 0. So ya is 0, right? And ya is 0 and yc is 0. So you put it in this equation here, where you would have incorporated in this expression up here, right? And therefore yc is equals to ya plus ut plus half gt square, or 80, whatever you want to consider there. And you put in that they are both 0. So essentially you're getting this expression equal to 0. That is essentially, but it's just explaining why the rationale between it. So this equation, we probably call your third or fourth equation of motion. So distance is equal to ut. If you had put 0 here and put in the value, you would have got it same way, but it's explaining where the yc come from. So we're saying ya is 0 at this point, and yc mathematically it's 0 at those points. And it's a parabolic, right? So here you put them in as 0. 5t times so this is the velocity times the time, TAC, and so 9.81 times TAC. Yeah, so we simply expand it and then multiply to get these terms positive so we can work with them a little bit better for those who want to appreciate the signs. So we multiply 2 by -1, so we get 4.905 times t square a minus 5 TAC equals 0. So here we say let t equal to TAC, so as we have a simpler workout. And then afterwards you could just simply say it, but so you simply put the t in here. So this you transpose over and you have a nice equation now. 4.905 t squared minus 5t equal to 0. This is in the form of quadratic expression. So we say at squared plus bt plus c equal to 0. And so we say that t is in this form to solve a quadratic that is difficult to solve and cannot be factorized, is minus b plus or minus the root of b squared minus 4ac. Of course, you know c is 0 in this, so everything down in this term here, so we'll drop out. But we'll put them in nonetheless. So you see a is, b is minus 5, a is 4.905, something there. So I simply put them in this expression here. This term goes, right? If I was to highlight it, everything in this part of this term here cancel out. All right, everything goes. So you're left with positive 5 because this is minus. And then this is going to be 25 square. Root, you're going to get 5. So it's going to be 5 from 5 at one option divided by this. So the time there is 0. And that's initially right at A here. So right at A, or right here, so where the body just start off, the time is 0. For it to reach C now, it is going to be 5 plus 5 divided by this. So you get 1.019. So it move, so it right at C. So this is at C. So therefore you can see, you can go back now to say that, if I was to put it in, come on, where's right now? You could say that TAC is equal to T, which is 1.019 second. All right. So you could simply say that. So that's what TAC is equal to. And then now it went on and asked us to find the velocity at which the ball strike the ground. Right. So what we did, we consider that when it's up here at maximum height, we know that its velocity, it stopped momentarily. So when it move off again, its initial velocity is 0 at that point. Right? And we need to find the final velocity before it strike the ground. So we know that the component, and we also know the component in the horizontal direction don't change. which is 8.66 because 10 times cost 30. So both it's when it start out at A, moving out from A, it have that velocity, and when it reach C, it still have that horizontal component. The horizontal component never changes. So at the maximum height, we say that the U is 0, initial velocity. So we need to find the final one that is going to strike the ground. We know that at maximum height it was 1.25 because we're working from there coming down, eh? So we put it in this equation here. So v square equals to u square plus 2ax, but it's vy square plus uy square plus 2ax times the x is the height. So we drop it in this expression here, and it's simply, and when you're coming down, your acceleration is positive, right? Because you're accelerating, move from that point now. You're acting with gravity. So your v squared work out to be 24.9174. Root of that give you 4.992, which is approximately 5. So it tells that the initial, the velocity striking the ground with the horizontal component would have been same 5. Now, they both have components. So in order to get the final velocity itself, we have to take Pythagoras of it. So we square the horizontal component, square the vertical component, and we take the root. And we simply put them in, and we get back 10 meters per second. So that proves to us that the body, what it strike the ground with, and so the initial velocity that it throws, it kicks with, is the same one it strike the ground with. So in this case, it is symmetrical. The last case, we know that up to the maximum height, it had a time of 0.5 something. We double that and we got 1.0195. And because it's a range you want, is all in the horizontal distance. So we know the horizontal component and we know the total time. Multiply them and they'll give us the displacement. It's 8.82 meters for your displacement. All right. So class, that's that. I will send you, and let me just pause the thing here. All right. When is it that you have exam again, guys? Remind me. What's your exam date?
It's the 9th of December.
The 9th. So you have about what now? About two weeks
We have
time?
2 weeks.
All right. If it's possible, I will one day, not now, probably next week or so before exam, I'll help you with some revision, but not now. I'm marking papers now, so I'm busy. Go and read up and practice all you can, and later down, closer, I will help you with some revision. All right, but not now. Not for now. Maybe latter part of next week or so, far down. The classes need to keep in touch with me, and I'll try if I have the time and you have the time, we can fit a revision session in online probably, rather than face to face, because I have a lot of papers marking. All right, so that's it.
Sir,
Mhm.
while you were talking in the recording, um, yes, sir, while you were talking in the recording, you said V in the horizontal, but it had VY. So,
Let me clarify that. I'll turn on back the recording, and let us clarify where you're talking about.
sir,
I'm
it's
gonna, I'm
still
gonna
recording.
resume. I'm gonna resume, and you tell me where, and I
No,
will.
sir, it says that you're still recording. So you don't have to turn it back.
I'm still recording. Oh, I had paused something. I thought I had paused it. I had paused. I wasn't recording. I paused it. I pressed pause. So where are you? Where we're talking now? Where in my I mentioned that.
Sir, you have to go back down.
Down or top? Top
Yeah.
one. Yes.
No, you'd have to go like back down where you have like your writing in blue.
Down here. Or front?
No, further down.
That's in the top.
Sir, you're going up.
Yes, but I'm saying I'm reaching maximum. Here you're talking about?
No, sir. As in, like, you know where you have like your writings in blue, as in down there, like down the page.
Oh, what? This one here? Here?
Yes, sir.
Yeah.
So while
Mm.
you were talking, you said V in the horizontal, but like right where you see at maximum height, Vy is equal to 0, and like they go into that whole calculation of Vy.
Oh,
That's
saying
what I
that
was thinking.
Vx and Vy. Right. So Vy here and Vx. And I would have squared them using Pythagoras to here. So Vx plus Vy square down here. So this Vx is 8.66, while Vy would have been 4.99 or approximately 5. And when we square them and we get the value there. Right. Yeah. It happens occasionally. Yes. Just point it out if it happened, and I'll just clarify. All right. Trying to go too fast. All right. Yes. So I will close off that and I will pause now. Yeah. Oh, I paused screen sharing, but oh, I get what you're saying. You're correct. I paused screen sharing, but not the recording. Oh, okay, fine. All right.